Hello, young apprentices. As the night of Halloween is approaching, the world feels a little bit more magical, right? So I believe it is a perfect opportunity for us to delve into the magic of SwiftUI animations as well. You see, SwiftUI has powers hidden within its source code, and these powers can transform your apps from simple to enchanting, and yet only a handful of developers use it. So in this session, I will try to uncover these secrets for you, these secrets to smooth transitions, playful interactions, and elegant effects that will make your users go, wow. So by the end of this session, I hope that you will be able to craft these nice animations like a true wizards. So grab your spellbooks, and here we go, our magical journey begins. And let's start with a short motivational video, a short showreel, let's say, of the animations in SwiftUI that are not so typical, but possible. So I hope you are a little more motivated now to learn more about the animations, but sadly, we must start with some basics. So when exactly does the animation happen in your SwiftUI application? Well, basically, you have a starting state in your application. It can be a position of this ball. And then you have an ending state of your application. And you want SwiftUI to do the smooth transition between these two states. And this is exactly what SwiftUI is capable of, doing this for you, so you don't need to animate all of this in between. You just say, I'm doing a change, and I want to animate it. And how can you ask SwiftUI for the change? Well, you have a couple of options. First, you explicitly say, with animation block, you pass the animation parameter there, and then do the state change. Or you can directly assign the animation view modifier to your view, also fill it with parameters, and whenever the value here, the X position of the ball, whenever it changes, the SwiftUI will perform the animation for you. It's completely possible to mix these view modifiers together. So for example, here we are changing the height of the rectangle with one animation and the width of the rectangle with another animation. And you may naturally ask, okay, what if I do multiple animations together? Is it possible? Well, it is, but up to some extent. You can assign again, multiple animations, and all the animation view modifiers basically affect anything that is above it. So in this example, we are changing rotation and the size of the rectangle at once. What is the magic behind that? And I would say this would be probably the more crucial information from this talk. Everything relies on this nice protocol animatable that basically exposes animatable data, and this animatable data is something, it's the mean of how SwiftUI is actually able to do this interpolation of animations for you. The animatable data need to conform to vector arithmetics, and I will immediately explain why this protocol, this vector arithmetics, is required. There is a couple of standard types that already conform to this protocol, like CG float, CG point, CG size. If you need to have multiple parameters and animating them at once, you can wrap one animatable into the animatable pair. And of course, you can nest it if you need even more parameters. And naturally, you may ask, okay, but I have a chart that has thousands of values, and I want to nicely animate the chart from one state to another. So what do I need to do? Well, the best way is to implement something like animatable vector that will allow you to provide the view with a bunch of data. The implementation can be very simple. You basically define your new structure with the, that conforms to the vector arithmetics. And you see here we have our values. It can be just the array of doubles, or it can be SIMD type, whatever you prefer. And we need to implement the vector arithmetics and additive arithmetics. Why do we need to implement exactly those? Well, let's see at this example. Let's set our starting state as V0 and ending state as the V1. So, and we want to animate from the V0 to V1 smoothly. So what do we need to compute? We need to compute a differential vector, which is the subtraction. And then during the animation for each vector VA, we compute it as a starting vector plus a scaled representation of the differential vector. And you see that this equation exactly covers the operation required by the vector arithmetics. You see there is scaling, there is multiplication, there is addition. So this is simple, and from the equation you already see that this interpolation is linear. It goes from one point to another point along some animation curve. But what if we want to do something like that? We have starting point, we have ending state, and we want to do the shift. But during the shift, we want to go through some intermediate state that is not so linear. Something like this. Or we might represent it with some curve like that. This is some sinus function. So what can we do about that? So let's create a view, and we conform it to the animatable. So we need to provide our view with animatable data. And here, our animatable data is basically offset factor. So this is the offset of the view from starting point to ending point. But we want to scale the view along the animation with it. So we provide it also with the scale factor that will control the scale of the movement, something like you see on the example. And the scale factor directly depends on the offset factor. You can see in the equation that we are calling some cosinus function. And what is happening is that the SwiftUI is actually interpolating the offset factor from 0 to 1, whilst we are recomputing it for the scale factor according to some nonlinear function. Now, you may ask why I have used the parameters from 0 to 1 for the controlling of the offset. This is something that I consider a great practice, to have basically everything normalized between 0 and 1, because it's easy for you to visualize. It's easy to understand that if some parameter is 0.33, that it's in 1/3 of whatever it is, even if it's like coordination on the screen or the timing. So it's very convenient to do so and not using the actual timing values or actual pixel values. So let's talk more about the timing. You may set any duration for your animation. And if the animation duration is in sync with your state changes, everything works as expected. Here we are doing updates every 2 seconds, and the animation takes 2 seconds. And the view moves along a line. But if we are doing the state updates more frequently, suddenly you see that the ball is not moving on the straight lines, but it's slightly curved. And when we are doing it even more quicker, suddenly the ball moves in the circle. What the heck? Well, the thing is that SwiftUI is performant enough that it does so-called animation blending for you. So basically, whenever you change your state and the animation is performing, SwiftUI starts to animate to a new state according to the new values, and it blends nicely the animation for you. At the beginning, it might be like unexpected surprise, but in the end, it might be reused for a nice effect. If your animation depends on multiple states, of course, you can chain multiple animations, or you can use a face animator. Face animator is available since iOS 17, and you basically can define a couple of states and then change the view depending on those states. To have it even in more readable state, you can even define your phases like the enum, and then define how these enum values affects your scales, your opacities or colors or whatever, like here on this example. And then in your face animator modifier, you are providing these cases and just specifying in the content part how this changing affect the content and what animations are used within each phase. So it's very performant for this purpose. If you need to go even more crazy and you need to do some multiple transformations and animations of multiple values at once following the different curves, this is also possible. You might know that, for example, from video editing software, when you might have different curves for different things in your video, and it's called keyframing. So you can define so-called keyframe tracks for offset, scales, colors, again, anything you define in your view, and just using the keyframes that will control these complex animations. Here we will see some examples from the documentation. We will see this wave gesture animation. You can see that there is a lot of things going on. So let's break it down. We can define the structure animation values that we will actually control the view. We will change scale, stretch, offset, and angle. And our view will have a keyframe animator view modifier assigned, where again, in the content part, in the first part, we just said that for the rotation, we read the value from the angle. For the scale effect, we read value from the scale, etc., etc. And what we need to do is in this keyframe part, just to define these keyframe tracks, basically these functions. And it may look a little bit overwhelming at first, but basically you can drill it down very simply. So you have, for example, for the scale, you have a first keyframe track, and it has a free keyframes with the different animations, with the different durations, and really it depends on you. And these keyframe tracks for the scale and, for example, for the offset, they are not depending on each other. So that is why it's very powerful and probably hard to be replaced with different approaches. Now, let's talk about the shapes. The shapes are also an entity in your SwiftUI that you can animate easily and with the same approach as anything else, but they can be used for nice ice candies. So for example, if you need an original slider that is not a rigid, but it's a little bit more bouncy, more, I would say more human, then we can easily do it. We can create a shape that will draw inside of you this rounded rectangle, and this drawing will be depending on the stretch factor. So basically, the more we are dragging the view out of the container, the more we will stretch it in a horizontal axis, and the more we will extend it in the vertical axis. The implementation takes just a couple of lines. So we define our slider shape. We have a squeeze parameter that is the controlment of the squeeze that I've shown before. We bound it to animatable data, so SwiftUI knows that it is possible to interpolate this value. And then in the function path, we just simply draw this rounded rectangle. And that's it. Another example might be something like this. You want some progress indicator in the forms of waves, for example, for tracking the daily intake of liquids. And again, the animation, the structure here is we provide it with the water level and with water offset, wave offset here, which is basically the height of the water and the offset of the waves. And we will implement it as a linear interpretation. So basically in the one big for cycle where we compute the small lines that will form this wave parameter. For the eye candy's sake, of course, you can merge it for multiple layers, so it looks even better. But the idea here is hopefully readable. If we need ongoing animations, this is slightly a different story. So far, our animations were like, we do state change and we want animation. Of course, you can define that the animation is indefinite, but it's not the best approach. The better approach is to use so-called timeline view. And the timeline view basically is able to redraw your view according to its parameters. So in this case, we want have really quick updates with the animation and minimal interval, so you can define how quick these updates should be. We want it to be like fluent for the eye. And then within this timeline view, we get the timeline parameter where we can read some time and when we can adapt this time to our needs. So here, again, we define that we want like continuous animation updates. And we bound the time parameter to our shape input like wave offset. So basically the horizontal offset of the wave will be controlled continuously with the time. And voila, you have indefinite animation that is being controlled forever when your view is on screen. You see the custom shapes are really powerful for your custom views. And also if you need something like the shape morphing. So you can define your shape like the set of points, and then you can transform these points from one shape to another. Again, this can be used in various situations, so not just like this example when we are transforming from one shape to another shape. But if you take this shape and assign it as a, let's say, clip mask to your view, it can also be used for the transition effects, something like that. Or if you are working on really custom applications, you can create your sci-fi HUDs or sci-fi components, and this is everything created using custom shapes and animated. And the last example, even such things like fire or your view on fire, it can be implemented as a custom shape. It's a shape that actually takes some vector path as an input, so it can be reused like from the heart to your rounded buttons or even entire screens. It really depends on you. And just the idea of how to implement this is that we can trace the original path of our view or vector or whatever we are using. And I'm doing random offsets along the paths, and I'm connecting these random offsets with lines. So this is how the shape, new shape from the original shape can be created, and just fill it and use multiple versions of it so we can have like these yellow and orange edges of this fire. So this is, I would say, a little bit of hacking, but it's very easy to do very simple effect that can be scaled within your applications. Now, let me talk a little bit more about the particle effects. Particle effects can be very helpful in some situations, probably more in games, but I would like to demonstrate a couple of concepts here, so bear with me. So if we want to create particle effect in SwiftUI and not using something like a SpriteKit integration, we can start with the motion. The motion here can be implemented as a geometry effect. It can be implemented also a different way. This is just for the example where our effect is basically the equation of the simple throw. And we initialize this effect with some random values. So anytime it is being assigned, it will move a different velocity with different direction. Now when we have our movement, let's create a particle effect and emitter from it. So let's start with actually assigning this effect into a view modifier so it can be reused. And then we combine a couple of views with these effects together. So we have a bunch of moving hearts. And now we need to fine-tune it. So for example, what we can do within this view modifier, we can assign a scale effect, and then for our input parameter, which is basically the time, and the time again goes from 0 to 1 because it's very convenient, we can change the scale during the movement. So it's kind of nice animation. We can add another modification and bind this time to opacity, or change the hue rotation to have a more variety in the effect. So with this idea of wrapping everything into view modifier, we are again utilizing one of the SwiftUI power, which is the reusability of view modifiers. So you can take this effect and, for example, put it on your standard views, and suddenly they will populate in this particle effect. This is the same case with just slightly different views assigned. But natural question is this the right way to do that so? Well, there are better ways, so let's go with a couple of them. You see, the more views you are using, the more system resources you need. So for example, if you have thousands of particles to animate, it is not wise to have each particle as a view. One of the ways is to create a shape that will basically draw these couple of particles together. So here we are having multi-particle shape that contains a couple and draws a couple of particles depending on the input vector. Here, this is what we have implemented in the beginning. And I've used it, for example, and here we are just drawing rectangles, nothing fancy. But I've used this code, for example, to create this simulation of the Chladni patterns. This is, for example, when you have sand on the plane and you are playing sound on it, then the sand forms these patterns. So this can be, for example, implemented using a custom shape, which is great, and it is kind of performant, but you might have issues with the blending effects. So if you need to go a little bit more deeper, probably the best way how to implement particle effect like this one that look really magical, it's to draw it directly on the canvas. The canvas drawing are very fast, and one of the best feature here is that basically in the symbols part on the bottom, we define these particles that we are using, and the SwiftUI pre-renders them, so the reusage is very quick. Another chapter here would be the transmutation, which is utilization of the view modifiers. And one of its features that in the body of the view modifier, you have a content parameter, and you can do whatever you wish with this content. And the question is, okay, what if I take multiple clones of the content, like this, within the Z stack, and I change them in some way? Can it be helpful? Well, yes, it is very helpful, especially for transitions. So let's go with some examples. We have our view, and we want to create a transition that basically turns this view apart You can have it like when going from one screen to another screen, or just because it's nice. So how to implement it? You see, we divide it into 4 quarters, and we will move each quarter in a different way. Even though it might sound very complicated, it's actually not complicated. And you can see that we have our modifier. We create in the Z-stack 4 copies of the content, and each copy is masked with a quarter mask shape. So we are taking only 1 quarter of the shape and changing its offset according to the input parameter. And then we will do the input parameter change. And everything can be wrapped into a transition, so you can create a new transition like this on the bottom, and suddenly you can reuse it, and you can reuse it for any transition within your apps. If you need to create even more crazy things like these waving flags or whatever, the only probable things that you can go to is using shaders. Sadly, shaders are a little bit over scope of this talk, but I just want to let you know that there is another way how to turn and change your views. Just for a quick demonstration, you can have view, and you can assign a distortion effect, and within this distortion effect, we create a shader that only what it does is that it changes the vertical axis of the pixels according some sinus function, which is readable at the top of the screen. So again, just for the completeness of this presentation, but it can be used in many other ways. So for example, here, you can have transition between your views, create some looking glass effects, or whatever your imagination lets you. The great thing about this cloning approach to your content is that you can assign it directly with animation with some delays. And then when you apply it on a view and do the changes like this, ball on the left, suddenly you get a nice trace of your history appearances of the view. So again, it can be used for example, loading screens or something like that. Again, this is just a single moving line with applying this view modifier that creates a bunch of clones and merges it together. Now I would like to talk something about the enchanting of your animations, and I would like to mention 2 of my favorite view modifiers. And this is a little bit of blurring and using the blend mode with the plus lighter. What this does is that it creates this illusion of the lightnings. So if you are creating any plasma or lightning light effects, it can be created very easily using this approach. So this example, we have just 3 copies of the same line, the line of the lightning, and we are just merging them together, slightly blur, and utilizing this blend mode that the more lighter the color is, the more lighter it will be. The same idea with a different representation, creating plasma balls or lightning ball or lightning, something like this. If you want to be more crazy, of course, since iOS 17, you can utilize the shaders using color effect, layer effect. Again, as I said, this is slightly beyond the scope, but for the sake of completeness, let's have it here. And I would love to forward you to this site. This is absolutely the best starting video if you want to learn more about the shaders. So it has like 40 minutes, and it will learn you a lot. Really the best material I have seen so far, so recommend. Now we will be slowly wrapping it. We need to talk about how these animations might affect the performance of your app. You see, in this example, I went slightly overboard with the animations, and of course, in your real apps, you need to be more cautious what you are doing. So always remember these couple of rules. always use the same number of views. The more views, the more troubles you might have. Also, take care of your drawing complexity, especially when you are using canvases. So the more paths you are drawing, the more bitmaps you are using, the more resources naturally you will need. For some simple drawing or some simple views, you can just assign directly drawing group view modifier that enables metal acceleration, and it will be fine. Sometimes you need to fine-tune it more. But as I said, the canvas with resolve symbols will solve a lot of problems for you. And of course, if you need extra mile, just use shaders. I would love to talk about one more topic, and this is how to render these animations. You see, since iOS 17, you can render any view in SwiftUI using image renderer. It's really great. You can render anything off screen up to 8K resolution. And it's really 2 lines of code. You just create image renderer for some view and then ask for the image. So for example, here I have created this complex view and rendered it in off screen. So you can see it's really detailed up to 8K. And if you go through the documentation, the renderer has object will change publisher, which you can react to and sync to. And the question is, will it allow me to render my animation in SwiftUI? Well, sadly, no. You will get this publisher only when the state changes and not during this interpolation that SwiftUI does for you. So sadly, if you need to render your animations, you need to basically capture the whole screen and not just react to this publisher. Now, the question is, so what is the magic behind this SwiftUI animation? Well, sadly to say, it's linear algebra. It's all about vector arithmetics. It's all about being oriented in 2D space. But don't be afraid of it and experiment and play with it, because I guarantee you it's very addictive. And I urge you, you shall animate your applications, you shall animate your views, and make enchanting apps for your users. Thank you for your welcoming here. If you need more, I have some blog posts on my website, nerdiat.tech. So some of these topics that I've been presenting here are written there in more detail. And big thanks to the organizer of this lovely conference for having me today. This is all.